This video is for those of you interested in trying to draw a trinucleotide. Why is this considered a chapter 25 and 27 video? Well, carbohydrates are involved. In 25 and 27 involves nucleotides. Here are the nitrogenous bases that many of you have heard about in your biology classes. Adenine, cytosine, guanine, thymine, and uracil. If there are two rings present, as in guanine and adenine, we call those purines. And if there is one ring present only, it's a pyrimidine. We can bring these molecules together with hemiacetal from a sugar, and an amine will react, creating the N-acetal. It's an acetal, but it's got nitrogen instead of oxygen. That's what N-acetal means. An older expression is, careful how you say this, it's an aminal. And any reaction that takes two smaller molecules and brings them together to make a bigger molecule and loses water, yes, you remembered, it's called condensation. And here is another condensation, a derivative of phosphoric acid. In fact, that's the one at pH equals 7.4. This is how phosphoric acid looks. It can react with an alcohol and condense to make a phosphate ester while losing, you guessed it, water. Okay, the hemiacetals used to make trinucleotides are derived from ribose. You will not be told that on the test. You are expected to draw ribose. Now, if there is no oxygen on carbon 2, it's called Deoxy Ribose. The short form, when I want that, is a little d in front of the letter. My only Deoxy Ribose will be in the second nucleotide in my trinucleotide. This one will have the full OH of ribose and the other OH of ribose. If you had the structure of ribose here, which you do on your handout, you'll know both those OHs are down. Ribose has the CH2OH up here, OH. We're going to connect this molecule to a nitrogenous base right here. So this will be a nitrogen when we're done. The question is which of the many nitrogens over here to use. We will review that shortly. When we do have a nitrogenous base on a ribose, it's called a nucleoside with an S. Right after I add the phosphate, it will be a nucleotide. The R group is the ribose. So, get rid of this and connect them. If this nitrogen is one of the nitrogenous base nitrogens, this would be a nucleotide. I'm going to leave the nitrogen there because we're going to put one of those bases there. Let me outline what you need to do to make your trinucleotide the minimum structure you'll have for all of the possible questions I could ask. Let's just take it from here, because sometimes I don't even tell you to put a phosphate up there. If I didn't indicate a phosphate was present on that end, which is carbon 5, we call it the 5' end. It's carbon 5 of ribose. If I didn't tell you to put something there, then you would leave it like this. There will always be a phosphate connecting carbon 3. So this oxygen here will be a phosphate. 3 phosphate. It's a phosphodiester that links it up to another ribose. So let's grab another ribose up to the carbon and connect it. So there's a dinucleotide, 2 riboses. There will not be a charge on this oxygen anymore. So that's a dinucleotide, and a trinucleotide would have yet another one of these down here. Sorry, this moved a little bit. No matter what happens when you show up and you see the trinucleotide question, you will have drawn this as, quickly and steadily as you can. Look at the name carefully. Which of those R's are normal riboses? In this example, the first one, which doesn't have a D, and the third one, which doesn't have a D. So I'm going to just leave the minimum over here. And we'll put our final answer over here by editing our minimum. If it's just an H, then we can get rid of the R entirely. And we can put an OH for all of these. Got that part taken care of. The nitrogenous bases we're supposed to use for our first one is adenine. And let's look at the purines as a pair first, because we have to figure out which of those many nitrogens gets used. Okay. If you have the small 5-membered ring, that makes it easy. You pick the nitrogen in the 5-membered ring that can undergo a condensation reaction. The other nitrogen that I'm not highlighting in blue here does not have an H. It cannot do a condensation reaction. Do not use it. You will lose a full point if you use it, because you will have drawn something that didn't happen. I know my question actually says this does not happen. I just picked a trinucleotide that had both deoxy and normal ribose. That's not normal in nature, but you know, I'm supposed to test you on these things. Okay, so the blue ends are there. And when you have to pick from the pyrimidines, please don't pick the nitrogen that's exocyclic. That's the one outside the ring. Don't pick the one that doesn't have an H. Same reason as before. So pick this one that's an amide. And in fact, just remember, pick the amide, not the... This is an imide over here. Don't pick that one. I know it's got an H. You want to pick it. It's not an amide. It's an imide. Helps to remember your functional groups, doesn't it? Okay. So those are the blue ends. So I can do this. Sadly, you can't on a test. I'm just going to get this thing here, flip it, and I'm going to erase that because the blue end's right here, and it's not bonded. When I form the bond, N loses its H. And if you drew it down here, it's wrong. Trinucleotides do not have beta linkages to the nitrogen. Sorry, I said that absolutely wrong. Do not have alpha, which is what I have pictured here. They are beta. I need to see your nitrogen clearly on the same side as the distal carbon. So that's the A. Next one is the DT. You're going to grab this. Thymine has a methyl there. Please don't leave it as an R. Tell me you know how to read the R equals CH3 and put a CH3 there. And get rid of this N. Rotate this around and connect it. After we connect, it's clearly beta, sticking up, cis to the CH2OH. And our last one is cytosine. Almost finished. We have to take care of our ends. We're told we need a phosphate on the 5' end. Hey, that's what I drew the first time. I'm going to move this over to here because that's the one I want. So we have a phosphate group over here on the 5' end. And the 3' end is this down here. There's got to be something there. And that is carbon 3 of ribose. 1 is the anomeric carbon, 2 is there, and 3 is there. And we want to draw a pyrophosphate. What does that mean? Well, in English, the word pyro, as in pyromania, refers to heat. If you heat up phosphoric acid, you can make it form a anhydride, a dimer. And that would look like 2 phosphoric groups linked together with an anhydride. So we got one right here. And I'll put another one right beside it. Pyrophosphate is also called diphosphate, and we need to link it up where it belongs. So I'm going to connect this O is one of these on the end, and I will make it happen. And there you have it. We have our ADTC, adenine nucleotide, thymine nucleotide, cytosine nucleotide. The backbone is here. We have to do that first, and then we build on it. When it's deoxy, we leave a carbon blank. When it's normal, we have the OH. And I hope you found this video on drawing a trinucleotide helpful, and I look forward to you doing it on test 4 and getting full credit. And I look forward to our next video.